Hi, all. Welcome back to the memory management series of operating system. And in this video, in this lecture, we are going to learn about paging and some questions related to how paging is being done. So let's look over that. So first, we'll start with a question in which we have a system. Okay, so there is a system, and this system has and LA, you understand that is logical address that is of 27 bits, and the physical address is of 21 bits. Page size is given as 4 kilowatt word, and memory is word addressable. Okay, memory is word addressable. So these are some specifications given about the system, and we need to calculate the number of frames and the number of pages. So it's a very simple question. So we all know that the page size is equal to the frame size, because whatever there is the size of the page that will be brought into the main memory, right? So the page size is equal to the frame size. Now, if we talk about LA, so if LA says it is 27 bits, in that LA, some bits are allocated to the page number and rest is the page offset. Okay. Similar way, if the PA it says that it is 21 bits, in that some bits are being allocated to represent the frame number and rest as the page offset. So this is same. Okay. Now page size we have been given as 4 kilowatt, that is 2 raised to the power 2 into 2 raised to the power 10 word. So let's say if the page is 2 raised to the power 12 word, so this represent the number of pages and this word represent each row content. Okay, so number of pages will be 2 raised to the power 12, and 12 bits would be used to represent each page. So this D becomes 12 bits here and also here. So out of 27, if we provide D 12 bits, so how much page bit will be there? So it will be 5 and 1, 15 bit, right? So if someone asks number of pages, then it is 2 raised to the power 15, that is 32k pages. Okay. And if we talk about this physical address, so 12 bits are being allocated to this. So 21 minus 12, that is equal to 9. So 2 raised to the power 9 frames will be there. That is not, that is just 512. So number of frames become 512 and number of pages become 32k. So this is a very simple question regarding calculation of number of pages and frames based upon the logical address, physical address, and one more information is given as page size is 4 kilowatt. Now, some questions will be like, we have to consider a system, and the system is having number of pages equal to 8k. So now you have been given the number of pages, so you can represent the D offset, that is 2 raised to the power 3 into 10, that is 13 bits. Okay, so D is given from here. Now page size, okay, sorry, it's not D, it's P, right? Number of pages. Now page size is given as 16 kb, and from here you can calculate D, and that is 2 raised to the power 4 into 2 raised to the power 10, like it is 14 bits. Okay, so D is 14 bits, and number of pages is already given, that is P, that is 13 bits. Okay. Now memory is byte addressable. Okay, and physical address, that is PA, is given as 22 bits. Then you are asked to calculate the logical address and the number of frames. So some informations are given, some are missing like that. So logical address is P plus D. So P is already 13 bit, and from page size we can calculate D as 14 bits. Why? Because memory is byte addressable. So each row holding 1 byte of space in the page size. So if this is a page, right, and it contains 16 KB, so there will be 16K row, each row containing 1 byte. So total number of rows will be 2 to the power 2 raised to the power 4 plus 10, 14. Okay, so 2 raised to the power 14 pages will be there to represent 2 to the power 14 pages. 14 bits is required, so D becomes, page offset becomes 14 bits. So D is 14, and already we have been given number of pages 8K, so it is 13 bits. So altogether 27 bits. So LA becomes 27 bits. Now number of frames can be calculated by PA minus D. Okay, so PA physical address already given 22 bits, minus D is 14 bits. So your number of frames, F becomes 22 minus 14, that is 6, 7, 8. So number of frames can be 2 raised to the power 8, that is 256 frames. Okay, so this way you can calculate regarding, from some given information, you can calculate the remaining informations. Okay, similar way, there is a question with LAS. Just a second. Okay. LAS being given as for any system, we have been given the LAS. LAS, that is logical address space. Okay. So it is given as 128 megawords, and physical address is given as 24 bits, right? And PA is divided into PAS means physical address space is divided into 8K frames. So now F is given to you. Now if 8K frames means 2 raised to the power 3 into 2 raised to the power 10. So F is given as 13 bits. PA is 24 bits. Okay, so you can calculate from here D, that is 24 minus F, that is 24 minus 13. Sorry, PA minus F, 24 minus 13, that is 1, and this is 111 bit. So D is 11 bit, right? Now from D you get the page offset for this LAS as well. Now it's asking how what is the page size. So page size, if the memory is word addressable, from here it is clear that memory is word addressable, so it is 2 raised to the power D into one word. Okay, because D is the page offset, so total number of rows in the page is 2 raised to the power D, that is 2 raised to the power 11 words. Okay, and it is equal to 2K words. Okay, so page size is 2K W. And if someone asks about the logical address, so logical address is nothing but logical address space upon each page size. Sorry, not logical address, the page number of pages equal to logical address space upon page size. So it is 12 128 megawatts by 2 kilowatt. So this is 2 raised to the power 7 and 27 word upon 2 raised to the power 11 word. So it is equal to 2 raised to power 16. 2 raised to the power 16 word. Okay, so number of pages, sorry, not word, word will get cancelled. So number of pages becomes 2 raised to the power 16. So if we are asked about the LA, so LA is equal to P plus D. So P will be represented by 16 bit, and D is already we have been given D 11. Okay, so altogether it becomes 727 bits. So LA becomes 27 bits, and we have a second thing, that is page is 2 kilowatt. Okay. Okay, now next question. Let's come on to next question. So as these questions are just based on the data, you just have to interpret the data and calculate what is required to find out. Okay, so let's come to next question, in which we have the LA being given as 32 bits and the PAS is 64 MB and memory is said to be byte addressable. Okay, memory is byte addressable. Now we have the page size that is given as 4 KB. Now we need to find out the page table. So to calculate the page table, we need to have the number of pages into each PTE. Now PTE consists of the frame number. So number of bits used to represent the frame number, that is frame bits. Okay. So from here we can calculate the page number of pages from this LA and page size. So if LA is to 32 bits, then LA equal to P plus D, and D can be calculated from this, that is page size is 4 KB, so 2 raised to the power 12 byte is the page size, and memory is byte addressable, so 12 bits are used to represent the page. So D becomes 12, and LA is already given 32 bits, so you have to find P, so P is equal to 20 bits. Okay, so now we have number of pages equal to 2 raised to the power 20. Now PTE contains the frame bits, so frame bits means the number of bits required to represent the frame. Okay, so that is we have to find F. Now from PAS and page size we can find the frame bits, so a number of frames equal to PAS upon frame size, so frame size is equal to page size, so frame size, so 64 MB upon 4 KB. Okay, so it is 2 raised to the power 6 and 2026 byte upon 2 raised to the power 10 into 2 raised to the power 2, so 12 byte, and it is equal to 2 raised to the power 4 and 1 14. So number of frames would be 2 raised to the power 14 and frame bit will be 14 bits. So now we have the page table size equal to 2 raised to the power 20 into 14 bits. Now 14 bits can be converted, can be taken approximate to 16 bit, and 16 bit equal to 2 byte. So altogether we can say it is as 2 byte. So it's 2 MB, because this stands for M and this stands for byte. So page table size can be 2 MB approximately, because we have just approximated 14 bits up to 16 bits. Okay, so this could be the answer for this. So it is 2 MB. Well, an important point to note here is that page table size, page table size is equal to number of entries, number of entries in the page table, that is the number of pages, into PTE size. PTE definitely consists of frame number. If there are other bits also present, they will be provided to you. Okay, so there are a few more questions that we are going to discuss in the upcoming video. So I hope from these basic questions the concept of paging is a little bit clearer, but we will talk about more in the upcoming video. So let's close this video for now, and yeah, if you do have any comment or questions, please do keep asking and in the comment section. Okay, so and we will be seeing some other questions in the upcoming video. So let's close it.